Differential and integral operations 8. Use the differential operator theorems to evaluate closed surface integral d sigma dot v. S is the surface of a sphere of radius capital R centered at the origin, and v is x to 5 e to ex hat plus y to 5 ey hat plus z to 5 ez hat. So we're doing part C of the problem now. Okay, so let's note that our vector v in this case is x to 5 ex hat plus y to 5 ey hat plus z to 5 ez hat. And now we need to find divergence of v. So let's work on the divergence of v. We take a derivative with respect to x. We obtain 5x to 4 for the x component. For the y component, we obtain 5y to 4. And for the z component, we obtain 5z to 4. So our divergence is 5x to 4 plus y to 4 plus z to 4. Okay. Now we're using Gauss theorem. What is the differential volume in spherical coordinates d tau? It is r d theta, that's theta is the polar angle, r sine theta d phi, phi is the azimuthal angle, and dr. So our differential volume is r square dr sine theta d theta and d phi. Okay, and the conversion between Cartesian and spherical coordinates, x is equal to r sine theta, projection onto the xy plane, cosine phi, y is equal to r sine theta sine phi, and z is equal to r cosine theta. So what is x to 4 plus y to 4 plus z to 4? That's what we need to figure out here. Okay, so x to the power 4 plus y to the power 4 plus z to the power 4 is r to the power 4 sine to the power 4 theta. R sine theta cosine phi was x, so cosine to the power 4 phi. And for phi we have r to the power 4 sine theta to the power 4 and sine phi to the power 4. And for the z, we have r to the power 4 cosine theta to the power 4. Okay. Now we're going to do the integral of the volume integral d tau divergence of v using the Gauss theorem. This is the volume integral v, and we already have d tau equals r squared dr sine theta d theta d phi. So because we have r squared, there's r to 4, this is going to become r to 6. And then we have sine theta, so sine to 4 will become sine to 5 theta cosine phi to the power 4. And dr d theta d phi, that's the first term. The second term, r to 6 sine theta to the power 5 sine phi to the power 4 dr d theta and d phi. right? And the last term is the volume integral r to the power 6. We have sine theta cosine to the power 4, cosine theta to the power 4, dr, d theta, and d phi. Okay, so this is going to give us, performing the r integral from 0 to capital R, it will give us capital R to the power 7 divided by 7. Now we have the remaining integral, double integral, sine to the power 5 theta cosine to the power 4 phi plus sine to the power 5 theta sine to the power 4 phi plus sine theta cosine to the power 4 theta d theta d phi. And for the full volume integral, theta goes from 0 to pi and phi goes from 0 to 2 pi. That's how we do the full volume. Now we have to deal with integral of sine to 5 theta d theta. So let's work on that. Integral of sine to 5 theta d theta. This is integral of sine theta cosine to the power 4 theta. So 1 minus cosine square theta is sine square theta. So sine square theta square is what we obtain, d theta. So let's call u is equal to cosine theta, du is equal to minus sine theta d theta, and we have cosine 0 equals 1 and cosine pi equals minus 1. Okay, so this integral will then become integral 1 minus u square square, and sine theta d theta is minus du. So this is going to become 1 minus 2u square plus u to the power 4 minus du. And this is operating the minus sign here, 2u square minus u to the 4 minus 1 du. So we're now ready to perform the integration. 2u square becomes 2 over 3u cube. U to the fourth power is u to 5 over 5. And then we have minus u. This will be evaluated between theta equals 0 and theta equals pi. Theta equals 0 corresponds to u is equal to 1. Theta equals pi corresponds to u is equal to minus 1. Okay, so this will give us, let's switch the limits here and multiply it by minus 1. U to 5 over 5 minus 2u cube over 3 plus u. Now I'm switching the positions of the limits, minus 1 to plus 1. And this is equal to, if I substitute 1 here, 1 over 5. And for minus 1, I will have minus 1 over 5, but minus minus will become plus. So the first term is 1 over 5 plus 1 over 5. And then I have minus 2 over 3. So u cube will give me 1 minus 1 will become plus, so this will be minus 2 over 3 times 2. And then I have minus u, which is, it's plus u, which is plus 1 minus minus 1, that is 2. So this will give me 2 over 5 minus 4 over 3 plus 2, which is multiplying this by 6, I obtain, multiplying it by 3, I obtain 6. And I have multiplying minus 4 by 5, I have 20. And then 2 by 15, I obtain 30 divided by 15. So I wrote the common denominator. So 6 over 15 is 2 over 5. Minus 20 over 15 is minus 4 over 3. And I have plus 2. So this is 30 minus 20, 10, 16 over 60, 16 over 15. Okay, now going back to my integral, the volume integral d tau divergence of v now becomes capital R to 7 over 7 from the R integral, 16 over 15 from the theta integral. I have integral for phi 0 to 2 pi sine to 4 phi plus cosine to 4 phi d phi. And for the other part, I have R to 7 over 7. The phi integral gives me 2 pi. I have the theta integral remaining 0 to pi sine to 5 theta. So it was sine theta cosine to 4 theta. So this is sine theta cosine to 4 theta d theta. And here I'm going to call u is equal to cosine theta again to perform this integral. All right, so here I have 16 capital R to 7 divided by 105. The integral from 0 to 2 pi. Now I can write sine to 4 theta plus cosine to 4 theta as sine square phi plus cosine square phi square minus 2 sine square phi cosine square phi. So that's this integral, the first one. And as for the second one, I have if u is equal to cosine theta, remember du is equal to minus sine theta d theta. So I will have a minus sign here. 2 pi capital R to 7 over 7. And it is now u to 4 theta d theta, u to 5 over 5, cosine to the power 5, cosine to the power 5 theta over 5, which will be evaluated between 0 and pi. Okay, and this is going to become 16 capital R to 7 divided by 105, integral from 0 to 2 pi, sine square plus cosine square is 1, so it is 1 minus 2 sine square phi cosine square phi d phi. And here I have, for pi I obtain minus 1, and for 0 I will obtain 1 minus 1 minus minus 1 will be 2. So this will be minus 1 will become minus 2, so this will be plus 4 pi capital R to 7 divided by 35. That's that part of the integral. And now continuing to work on the phi integral here, the integral of d phi will just give me a 2 pi here. So this will be 32 pi capital R to 7 divided by 105. And then I have the remaining integral minus 16 capital R to 7 divided by 105 integral 0 to 2 pi 2 sine square phi cosine square phi d phi, and then I have 4 pi capital R to 7 divided by 35. All right. And now I can write these two with the same denominator. So 35 multiplied by 3 is basically going to give me 105. So 3 multiplied by 4, 12 plus 32. So this will give me 44 pi, because I will obtain a 12 here. 12 plus 32 is 44 R to 7 divided by 105. Then I have minus 16 R to 7 divided by 105 integral from 0 to 2 pi. 2 sine phi cosine phi is sine 2 phi. And 4 sine square phi cosine square phi is sine square 2 phi. So this is sine square 2 phi divided by 2 d phi. All right. And now I recall that cosine 4 phi is equal to 1 minus 2 sine square 2 phi. So I will use this trigonometric identity. So this will give me 44 pi R to 7 divided by 105 minus 16 R to 7 over 105 integral from 0 to 2 pi 1 minus cosine 4 phi over 4 d phi. Because for sine square 2 phi, I'm substituting 1 minus cosine 4 phi over 2. There's another 2 here. It's 4. All right, so this gives me 44 pi R to 7 over 105 minus this part of the integral will give me 2 pi over 4. So this will be pi over 2. So that will give me an 8 here, minus 8 pi R to 7 over 105. And then I have the integral of minus cosine 4 phi over 4 d phi. So that will give me, so the 1 over 4 will get rid of the 16. It will make it 4, and the minus sign will make it plus. So 4 R to 7 divided by 105. And then from the integral of cosine 4 phi d phi, I have 1 over 4 sine 4 phi, which will be evaluated between 0 and 2 pi. And now you can see that this will give no contribution. So this part will give no contribution. It will be 0. Therefore, I will find 44 minus 8, which is 36 pi r to 7 divided by 105. Which is our final answer for this part of the question. Okay, so this was rather difficult to deal with because when I take the divergence of this vector, I don't obtain something trivial as in the previous cases like r square or something. So instead I have 5x to 4 plus y to 4 plus z to 4. Now I can do the brute force method. The volume, differential volume is r d theta, r sine theta d phi dr. Theta is the polar angle, phi is the azimuthal angle, r is the radius. And for the transformation between spherical and Cartesian coordinates, I have x equals r sine theta cosine phi, y equals r sine theta sine phi. That basically takes the projection onto xy plane, and z is equal to r cosine theta. And x to 4 plus y to 4 plus z to 4, I substitute these three. And then I start taking the integral, volume integral, d tau, divergence of b. So I have to multiply all of this with r square sine theta. So this gives me r to 6 sine to 5, r to 6 sine to 5, and r to 6 sine theta cosine to 4 theta basically. The r integral gives me r to 7 over 7. The theta integral for sine to 5 theta d theta is performed here, gives me 16 over 15. And then I have the phi integral remaining for this part of the first two terms. And for the last term, I still have to take a theta integral of sine theta cosine to 4 theta d theta. So I use the u is equal to cosine theta transformation to take this integral. And for this one, I use sine square phi plus cosine square phi parenthesis square minus 2 sine square phi cosine square phi to write this and perform the integral. And here I have used for sine 2 sine square phi cosine square phi, sine 2 phi is equal to basically 2 sine phi cosine phi transformation. So sine square 2 phi is 4 sine square phi cosine square phi. Therefore, this is sine square 2 phi over 2. So that's for this one. And then I have used cosine 4 phi is equal to 1 minus 2 sine square 2 phi in order to solve this integral. And I finally obtain 36 pi r to 7 divided by 105.